Hi, everyone. Good evening or good afternoon. Hope you're doing well. Actually, I'm really thrilled to announce that I'll be back on stage after a really long break. I used to do EMC in Dubai, and tonight, here I am in Abu Dhabi Islamic Bank. I'll actually be really happy to share my knowledge and passionate my passionate solutions with the passionate audience of tech enthusiasts who are dedicated to building a smarter and more wonderful Abu Dhabi alongside us. To begin, the topic of this event is ChatGPT, Metaverse, and Big Data, the future. And I really can't wait to dive into these exciting concepts with you. One of the things that I really love the most is technology and the opportunity to share ideas and see them grow and flourish with the help of others. I'm honored to have the support of Mr. Saeed Mohammed and Mohammed Al-Idrous from Expert Mark Group, as well as the backing of the esteemed His Highness Sheikh Maktoum, who has been an inspiration to us all. As his subtitle suggests, we are committed to building a new reality and a novel future for the people of this region through Passion Bites Abu Dhabi. To begin with, a quick brief yet very interesting background of our guest Saeed Al-Shamsi, who is a businessman with over 12 years of experience helping companies in various industries to help solve their obstacles and achieve their goals. He founded Expert Mark in parallel, working as an HR specialist for UAE government for several top-tier positions. Mr. Saeed is known for his analytical skills and strategies which have helped many clients and is highly respected in the consulting industries. In all kinds of business, Mr. Saeed published numerous articles and content as infrequent guest speaker at business conferences and events. And about our honorable guest, Mr. Mohammed Al-Idrous, who is a multi-dimensional leader and business accelerator in the UAE. He is passionate about providing clients with transformative change and maximum value by solving business obstacles. He indeed is a team player with strong communication skills and has a proven track record of building relationships. We don't forget our other guest, Ms. Taiba Rafi. Taiba Rafi? Right? Am I saying it right? Yes? Okay. Arabic name, right? Taiba. Yeah, Arabic name. Yes. Yeah, well, she also has an extensive experience of working as an HR expert and brand manager for over 8 years. Yeah, she is working with Expert Work Group as a global head of HR and partnership manager. She is a strategic planner for branding, and she successfully develops and implements the effective brand strategies that immerse the brand awareness that drives and improves customer loyalty. Now, before I give the speech to Mr. Ravi Nair, let me speak a little about our Max Abstracts genius, Mr. Navi Nair. This is what they told me to tell, right? Max Abstract. Mentor, technology evangelist, and founder of Passion Bites LLC in Florida, United States. Navi Nair, currently CTO, CEO of Passion Bites of Florida, based information technology company providing consultancy to many Fortune 500 companies around in the field of distributed computing, big data, and cloud services. Ravi works heavily on big data ecosystem. Prior to this, he was the co-founder and the CTO of Percipient Digital Transformation and Customer Engagement Company based in Singapore. He has done implementations for State Bank of India, the world's largest bank in terms of numbers of accounts, and future general health and insurance provider, and many more. Mr. Ravi was SVP at Citibank, handling business intelligence and big data to United States and Singapore, and LATAM. Yeah. So through his amazing and through thought-provoking lectures, Mr. Ravi always seeks opportunities, help instill and encourage passion with engaging discussions and consultancy throughout. He is Amazon certified and an ACM member. Ravi was technical reviewer of the book, also a technical reviewer of the book, Mastering Hadoop 3, right? Yeah. Well, not to prolong, I'm just gonna give the word right now, so please hear and enjoy a rich talk and lucrative theory and practice from Mr. Ravi Nair.
Hello, hello. Good evening. Assalamu alaikum. I expected the hall will be too much full, but it's okay. Always, whether it is one person or two persons, it's always thrilling for me to talk on technology. And I love that. And I don't miss any minute of that, right? So please enjoy the presentation. And what I will do is I'll just go through some slides to get you into the context of the topic, and then we will dive deeper, and depending upon the time, we will play around. First of all chief guests, all audiences, my wife and my son hearing this from Florida, my great team in Pune, Thane, who are all listening to me. I can see all your names in the screen. Thank you for your inspiration. Vicky, the co-founder, India, you're also listening there. And all of you, I'm privileged to be here because this great country has taught me so much big lessons in the last 1 year of my work as a consultant to various industries here. Well, let's start and let's dive in, right? So, what are we doing? We are going to do the art of architecting the unknown. And always I tell, and if you look at my profile, LinkedIn, or everywhere, I will do, what do you do, Ravi? And I always say that I like architecting the unknown. And what's the reason why we say that? Because science, if you look, we never knew what was the shape of Earth. We never knew about the planets. We never knew about the things that were happening in the cosmos, the stars, the universe, Alpha Centauri. No, we never knew this. And we have moved from those unknown to known as we went along. The scientists like Galileo and all, they discovered that the Earth is round and all those kind of things. Telescopes came in. So science taught us move from unknown to known, right? But where are we and what are we doing? We are moving from the known data to unknown analytics of the data, which the world call as artificial intelligence, machine learning, data mining, data analysis, bringing results out of the data. So I like computer science. Why? Because computer science and technology especially teach us to move from known to unknown. That's why what we are doing is architecting the unknown. And when we talk about architecting the unknown, two things are very important in this current world. One, how will you manage the scale? Millions and millions, billions and billions of data points. How you will make it secure and how you will make sure that they are all accessible in a beautiful, seamless, unique manner. That's one. Then, Internet of Things. Every device is going to have some kind of transmission in the future, and all that data is going to be emanating from the telephone towers to devices to all kinds of things. How are you managed to going or doing all these things? So, let's just think what is happening in the world. I am inviting you to centuries before, where the first graphics was done. And I think by collecting so many articles, I found that this is something which I could find out as the oldest image I ever saw. And then came the next image, the first human imprint on a wall. And that is 18,000 before Christ. And then moving around to Egypt, then here, and then, and then you will slowly see the three dimensions are originating in the images. And then comes another image, and then you can see that artificial intelligence started creating images and expressions. So look at the evolution. And you can see now that this particular advertisement that you see here is created using artificial intelligence, where they create massive people behind an advertisement without needing to have the actual people available. Technology has grown. But the problem with technology is that, and that is what the two links are coming. And let me take the latest link that I read when I was traveling from New York to Abu Dhabi in Etihad. And this link is telling me that there is a new Drake song, and that Drake song has duplicated the great singer, and that singer doesn't know that that particular song was impersonated by an artificial intelligence algorithm. So what we can dream has got unexpected consequences in the industry. But we are privileged to make sure that we are using it well and we are using it properly, right? Now, coming back to what we are doing, what is software? Software is the invisible thread, and hardware is the loom upon which we weave the fabric of computing. So one very important thing that I learned in my past 22 years of experience is that if you don't know hardware, don't do software. Many of the people do not know that. First thing you need to understand is how the networks are, how the computers are arranged, how the data can flow in the maximum effective way, how the network should be configured, how can you avoid the formats in which the data is transferred. All these things are very important when you are doing with data. And of course, a great quotation by Steve Jobs, who said that you cannot do any hardware or any software without necessarily knowing hardware. So, we learned some of these points, and now let me dive into technology or the big data before going to other parts of it. 2008, big data. What came in? Hadoop came in. The name of an elephant, which is the first of its kind in the world of distributed computing, where they introduced the term MapReduce. I don't want to make you confused about the technological terms here. Assume that there is a library and there are 10 million books in that library. And if suppose one person is counting all that books one by one, how much time it will take? Maybe 2 days or 3 days it will be taking for counting all those books, right? Now, assume that instead of one person, you are dividing that work into 100 persons, and each person is counting each department of the books, and then aggregating that count into top 5 managers, and that 5 managers are counting all the numbers and then giving final result. How much time it will take? It will take very less time. And what is the trick? You distributed the computing. And that's what Hadoop has done. So there are some terminologies. You can see that the computation is getting distributed onto something called as data nodes. All this distribution happens there. And then on the left-hand side, you can see that like the library, books are counted by the managers. Each count is reported back to the managers. And then the manager is going to give the final result back. If you ever knew or heard about big data, this is the crust of big data. And now Hadoop 1 failed. After few years, it failed. Why? Oh, whenever you are counting all these particular tasks, you never thought about the resource allocation, the memory allocation, the CPU. Remember about the hardware that I told you? So they forget about hardware, and they created this particular architecture. And eventually what happened? Hadoop 1 failed. So what they did? They created some great persons to help Hadoop. And you can see all those persons are working now together. And they call it as resource manager, yet another resource negotiator, or yarn, etc. And they modified this Hadoop in such a way that it looks at the hardware allocation, networking, resource allocations, scheduling, etc. And then finally brings the result back. Huge success. And that's what yarn has done. But not enough. When yarn came in, Berkeley University in US, they started a parallel thread. Oh, your MapReduce, your Hadoop, everything is disk-based. And you know that writing the data to the disk of the system and reading the data back from the disk is a very, very heavy operation. As you can see here, if you are looking at the results of how the data is reading, the memory reference is 100 nanoseconds, whereas the disk seek is 10 milliseconds. And if you divide the efficiency, you can see that RAM access is 100,000 times faster. So what did they do? They created a beautiful architecture where they bypassed that Hadoop-based architecture and brought in the new way of doing the execution through something called as direct acyclic graphs, and that's how Spark originated. So Hadoop 1 failed. Hadoop 2 successful, but the problem is it is not fast enough because of the disk read. Then came Spark. Right? And now the world is relying on Spark for very high-speed computations, and it is one of our core expertise where we will be doing the massive processing of data using Apache Spark. So, fault tolerance and efficiency is getting executed by this yet another resource negotiator that I told you, and it was a successful invention which changed the big data industry in a massive way. After that, what happened? Yes, yarn was successful, and it was able to do one kind of processing, which is nothing but the MapReduce-based or Hadoop-based architecture. Now, assume that you have got a web application, you have got, let us say, an Microsoft Excel-based application, and you have got another type of application. Yarn cannot do all these things. And what is the best way of making all applications beautiful, packaged with resource negotiation? Kubernetes came in. And the whole world is Kubernetes, nodes, pods. And what you see on the top is called a node. And you can see that this red one, which is the Spark-based execution, is just one of the component in that. And all the remaining things are getting packaged together so that now you get a complete Kubernetes cluster where you can deploy different kinds of applications and yet get the benefits of yarn. And if you look at the recent news, you can see that Google has changed their Spark execution engine completely from yarn into Kubernetes. So in our architecture, what we have done is we have created this modern way of using Kubernetes and creating pods in which we logically separate all these units. And remember the beauty of these pods, if it is failed, it will come up. These pods have got a replica set so that fault tolerance is inbuilt. The pods cannot be accessed from outside, so it is secure. And these are all sitting in your data center, and it is not going outside your data center, so that your data is secured, well protected within a shell of Kubernetes managed environment, and it is allowing you to communicate each other using the internal network, so that HTTPS, certificate-based data transfer, everything is included beautifully in that architecture. And what Passion Bytes is providing is Sigma Data, which is a platform created with this architecture, where my Spark will be in one of the pods, my web UI will be in another application, my Grafana will be in another one, my dashboards will be in another pods, and everything is clustered together so that it is supporting of replica sets, fault tolerance, and scalability. Tomorrow, 100 users are coming in, I will add one more pod. And if it is becoming 10,000, I will add one more pod or 10 more pods, so that it is horizontally scalable and it is sustainable. If suppose a new technology is coming in, I will take out one pod and I will replace it with that new technology, so that you don't have to pay money for migrations and digital transformations, which is one of the buzzwords of the industry nowadays. So all these benefits are obtained by this particular architecture, and the entire platform that we are building is based upon this architecture, so that it is giving you the assurance that tomorrow, after 5 years, you don't have to think that my technology is gone, it became legacy, and I need to digitalize again, and you don't have to hire a new CTO and new people. And that sustainability and that vision is in mind by seeing this great country and similar countries in the world. Why? Because look at how a desert got transformed into a vision which everybody is proud of. I'm talking about none other than the late Sheikh Khalifas and the visionaries who helped us for doing this particular thing. Bring that into architecture. Apply that into the architecture in such a way that you are creating something which can exist beyond 50 years. Tell me one technology which is existing for last 50 years. IBM, CICS, bank software. Another application is Oracle, which I have seen. Widely, news, beautifully written, rock-solid application. And architecture should be like that. Architecture should be in such a way that the replacement is plug-in, plug-out kind of, the approach should be of that type. And now comes another buzzword, right? What is that? Machine learning. And if you look at the definition, nobody is going to understand it. It is made so complex, right? Look at that. A computer program is said to learn from the experience E with respect to some task T and a performance measure B. And if performance of the task T is improved, it is called machine learning. Is the official definition. Don't worry about the official definition. I'm going to make you leaders of machine learning when you go out of this room. Okay? So how are we going to do that? We are going to play a small game. And that game will make you understand in and out of what is machine learning. So let's play a game very quickly. I'm going to open the browser, right? And then I'm going to open a new tab, all right? A new tab. And let's open a file, right? File, open file. And I will go to one of my directories where I have kept some code for some fun, okay? So I'm going to go to TechOn, and then going to guess, and again going to go to index.html. Wow, May 12, 2023 seminar, hot and cold. So the name of the game is hot and cold, okay? And as you can see here, select a number between 1 and 15, and that's what it is telling, okay? And let's do a simple test, okay? I'm going to put a number 12, and I'm going to tell submit guessed, okay? Oh, cold. Try a greater number, it is telling. Okay, very good. I am going to put, let us say, 15 this time. And then let us say, submit guess. Oh, it is telling you 1. So, in 2 guesses, we reached the correct answer. And please observe what we are doing, right? In 2 guesses, you got the right answer. Now, let's pay one more time. Enter a number. I am going to put a number 2 and then click on submit guess. Cold. Try a greater number. And then I'm going to type, let us say, 12, and then let's see what is the answer. Hot, try a smaller number. Look at what you are doing, and you are doing an amazing machine learning within yourself. You are looking at a system, and you are making the system learn, and as you are progressing, the system is making you to come to the correct answer, which is what we call as model training, and finally getting into the result, which is related with how ChatGPT was trained and how ChatGPT got into production. Billions and billions and billions of times it was trained by this particular method of making it know the answer by the guesses, so that at each step it will be learning. And anybody, what is the name of this particular algorithm? Stochastic gradient descent. Okay, the stochastic gradient descent means that it is stochastic, it is learning each and every time, making you come to the result. Which is the fundamental idea behind machine learning. You will have models created, and the models will be trained, and then finally you will be reaching the result, and then you will be proceeding with it. Now if you look at the definition, you will understand it better. Why? It is telling that the experience, learning from the experience, is getting increased, and the performance of prediction is becoming more and more clear. That's what machine learning is all about, right? So data is always amazing. Anybody who know these numbers? Very, very famous numbers. 1, 1, 2, 3. What are they called? They are called as Fibonacci numbers. And if you look, you can see that 1 plus 1 equal to 2, 2 plus 1 equal to 3, 3 plus 5 equal to 8, 8 plus 13 equal to 21, so on and so forth. It will be going on. What is the magic in these particular numbers? Right? And it is very interesting that if you are looking at the data mining, relating the data with what you see, incidentally, it is one of the best natural phenomenon that has happened ever in the world, which makes me sometimes feel that is mathematics having any relation with the universe? Look at this. If you are looking at the solar system, it uses Fibonacci numbers. If you look at a beautiful flower which is organized automatically, it uses Fibonacci numbers. If you look at a storm's eye, it uses Fibonacci numbers. If you look at world's famous logos, all these use Fibonacci numbers. Just a fun fact to make you know that Fibonacci numbers are very much related with how the data is and how the information is. Always, data is much bigger, and from the data, you need to extract the information. And that's what data science and all the people want in the world of big data. Big data is there, data is available, and data is completely disparate at different sources. You need a mechanism to combine the data and extract the value or information from that particular data. And that's where big data and analytics is coming in. And we have amazing examples of it, right? One another field that is coming in is AutoML. If you use any of this software, and if you are giving the data, and you are telling that, okay, find out what is the best model which is going to give you the correct answer, it will run automatically some of the algorithms, and then finally will give you an answer, right? Now, look at this example. Anybody familiar with this example? Very good if you have logged into Amazon kind of websites. See? These are all users, and these are all the items. 101, 102, all these are the items. User 1 has bought 101, 102, and 103. User 5 has bought some of these items. And my final question is, what is the product that you are going to recommend for user 1? Any answer? I know you will be able to give the answer by looking at this particular chart. Why? Because this is only 3 users and 5 products. But imagine like an Amazon where you have 1 million products and let us say 10 million users. How, when you are logging into Amazon, it is going to give you the result in such a way that, okay, use this particular number. Very quickly, you can run an algorithm, and that's what I'm going to show you here. Little bit of coding, sorry for that. If you are going to, let's say, an environment where you have this particular code and then machine learning. And if you're, I'm using a library called Mahout, which is the predecessor of Spark, which I have already told you earlier. And if I am running this particular run 1, you can finally get within splash of seconds that I will be giving the user a recommendation for the product 104 in the diagram with a confidence score of 4.25, which means that very close. That means the user may buy it. Now you understand how Amazon is showing you all the recommendations. Why can't we apply it for the retail industry in Abu Dhabi and in the nearby region? Where you are having all these products and then we are going to tell that this particular product is being recommended. Oh, I'm sorry. May God bless. Okay, so the next algorithm that we are going to come is, again, a fantastic use case, right? Look at that statistics. This is, just assume that this is a basketball or a football match statistics, where the play happened either in the home ground or away ground. Then at what time? And then, like Messi, Fred is a great player. So is Fred starting the game? And who is the offense? Who is the defense? Whether opponents are tall or short? And what is the outcome? This is the past data. We have this data, okay? Now the question is this. Please tell me, tomorrow there is a match at 9 p.m. And this is the statistics. Tell me whether we will win or not by looking at that data. A beautiful classification example. Again, many use cases for this. Look at bank, look at oil and gas, look at retail. How are you going to give promotions? Looking at the past data and then deriving what is the result. How is it solved? It is solved by using a very complex algorithm called a decision trees. What is meant by a decision tree? It will give you a tree-like structure. For example, just look at this and then traverse this and then find out whether we will be winning or we will be losing. And internally creating this decision tree is a very complex calculation. There are dichometry algorithms and there are some information gains that you need to calculate. Look at how simple we can do this. And again, another demo where how easily you can do machine learning. So I'm going to use a nice tool invented by New Zealanders. It's called Weka. Weka is a small bird like kiwis. And this is coming from University of Waikato. And what I'm going to do is I'm going to click on the Explorer and then I'm going to click on Open File and I'm going to take that particular file that I have shown you, which is the basketball statistics file. So let's go to this directory. And then select that CSV file. You can see that there is a CSV file called basketballstatistics.csv. And look at what is happening when I am selecting this file. Immediately, it is giving the analysis of the data. How many success? How many failures? And now, all you need to do is to click on the classification algorithm, choose what you want. I am going to select an algorithm called J48, which is an open source version of the D3 algorithm for decision trees. And then I'm going to click on Start. And you can see that within a splash of seconds, all the complex calculations are calculated. And if I click on Visualize Tree, your tree is ready. 5 seconds, 10 seconds. And the source code is available. If you want it for very large data, take that source code and put it into your Spark program. And your Spark is running in Kubernetes, extensible. Good. So, knowing tools and applying that particular tools and integrating those tools into your application will do that magic of having the facilities for giving user experience a better way and making sure that you get the full satisfaction whatever you are assured to give, rather than relying on very complex, very costly, very advanced tools for which even 10% of usage is not there in the industry. So we packaged all this intelligently into one single capsule completely as I told you, which is in a Kubernetes cluster in your data center. Right? So that's decision trees, right? And now let us very quickly go to looking at the data, right? One of the tools that is integral in our architecture is Presto, which is an open source tool, which is very widely used in the industry by all these companies, and we have seamlessly integrated that particular tool into our architecture. Another thing that we use is S3, which is an abbreviation for Simple Storage Service, invented by Amazon, but it is a common word now in the industry, and also called as object storage. And the reason why we are using object storage is you listen from this particular experience that happened in Florida. You know that NASA, and including our Abu Dhabi a few days back, had sent so many mission control vehicles to moon. It is very easy to control the vehicle to moon from Houston's data center in Florida, or in NASA's office. Why? Because the time of transmission from that mission control vehicle, mission control office and the vehicle is very less. But imagine when you are sending a vehicle to Mars, which is multi-million times, distance is very high, you will not be able to control it from either Houston office or NASA's office in Florida. Why? Because the response reaches there in 8 minutes to 15 minutes. By the time the vehicle might have been destroyed. For moon, it is possible because the response time is very fast. How did they manage it? They created mission control within the vehicle. So when the mission control is within the vehicle, then there is no transmission time at all. And they controlled everything by encapsulating it. So the lesson learned is, as fast as possible, whenever you are doing the big data processing, make sure your data is very close enough with your processing engine. If suppose you are creating that architecture where your S3 or the type of storage that you are using is one SSD based or NVMe based, so that the read is very fast and it is very closer to the compute engine. Right? And I'm talking a little bit differently because Hadoop was the one which was tied up with HDFS and MapReduce together. But the problem with HDFS was the block size, 128 MB block size. But you have S3 now, where there is no limitation to the block size, and use the same approach where your Spark cluster is very close with your S3, just like the mission control is within the vehicle, then you get faster access. Again, untold truths, which you get only from experience. And that's what you need in a data platform. Going back, just read my articles. I will be sharing this particular deck at the end of the presentation, either in the LinkedIn and the meetup groups. You can just go through. And now comes one another important thing. What do you do in the future when you have big data, when you have the machine learning applications like chatGPT? The next thing is, how can you apply it into modern technologies? Earlier it was AR and VR, augmented reality, virtual reality, etc. But now the world is going to little bit ahead. So I want somebody, Shabir or anybody who can come here for wearing this Metaverse Oculus headset, and I can show you how this particular headset is visible in a computer screen. What he's going to do is he's going to wear this and he is going to cast it to the screen. Okay? So you will get, come in. You will get only a partial experience. Come on. No, Shabir. And you won't get the full experience like Shabir. For example, he's wearing this, right? And the world is going to this direction very soon. That is left and right. Yeah. So wear this. And let me talk about you. This is an Oculus Meta Facebook's device. And now he's getting into a completely different world. And please take my word, may not be the next generation, but generation after next, 24 hours are going to have this. Or they are going to be having a spectacle like this, which will be an improved version of this and cheaper. You know, when car was invented, nobody was approaching car, you know. They told that this will kill the whole family. Cars. It's very dangerous. And now you know what happens, right? There is hardly anybody without a car. And that's what is exactly going to come. Every technology comes with a punctuated equilibrium. It takes time. And it will be, completely been immersed into the world. Why? Because this is going to give you that. So, did you cast? Okay, 1 minute. So, he has casted it. And I'm going to show you what he is going to see there. So, let me escape and go to the cast button where if I have connected into the same network, I can cast it. So, I will go to the Oculus camera site. It is oculus.com/casting. And then let's wait. Yeah, now you can start casting. You have to select camera. And then click on cast. It will take a while. There is network. And it is coming through wireless. Again, remember about the mission control. Wherever network is coming in, there is a small problem. And what he is now seeing, what inside he is seeing is left, right, up, down. Everything is a different world. Right? It started casting. Okay? Look at that. But what you are seeing is a very, very partial view of what he is really seeing. And you look up, you look back, you look your side. He feels like he is there in a different world. And amazing applications you can build by these things. Think about training. Think about a distant oil and gas refinery where rust is to be removed and that has to be taught. Currently, how the training is given. All the employees will be taken to that place and will be given the training, right? If you have this and he has that control in his hand, by sitting in the home, he or she can get the training and then apply the technology. Right? Do you want to show how you will be moving your hand? And okay, close this window, casting window on the left side. Yeah, close. Look at that. Here's the mouse he is using. And then go to the quick start screen that you see on the right side. Yeah, that is the menu. So, yeah, that's the one. That's the one. Yes. Click on that. Yeah, click. Yes. Just watch what is happening. It's blank? Oh, it's coming. Yeah. So he's in a galaxy now. And the way that he is seeing is unimaginable. And this is exactly what Metaverse is bringing you. You are going inside the internet rather than you are looking outside. Now as a spectator, you are looking outside the internet. And go inside. Ravi sir, imagine that you are troubleshooting a printer by using the camera sitting in your office. So there are some parachutes and there are so many things, right? Yes. Yeah. So that's what a metaverse world will look like. I believe that you might not have seen this particular device. If you have not seen, this is an opportunity where you can see it. Okay? If anybody wants to try it, please come later. You can try it, okay? Yeah, thanks. You can just keep it back. Right. So, what is the advantage? Now I am going to tell you that what is the vision that we have if suppose this particular, the metaverse world is there, okay? So I am inviting you to a modern shopping mall, right? Please watch. And you are sitting in your home. There is no Alwada Mall. There is no Madina Syed. You are in your home with the metaverse. And now you want to do a shopping. You are sitting in your home. And you go inside the shopping center. However big, however perfect, however difficult I want to make, or however luxurious I want to make, I can make the shopping center. See, I am going inside the shopping center now. Oh, it has got chairs, it has got sitting, and you are sitting in your home. And if you want to move to the chair, you will be moving from in your home from one chair to another chair, but that will give you the simulation that you are in the real shopping mall. And you have got everything there. You have got escalators. You have got all the things. You have got a big shop. And you have got all the items inside the shop. Maybe your friend is telling that let us meet in the Alwada Mall, but you are sitting in your home and meeting your friend and talking. All the things are there. And now let me tell you the user experience. User is coming in, logging in, and this is you who is going. You don't know which floor what it is. Going to the desk, asking, where is it? And you are getting a menu immediately. Okay, this floor, what is there? All the things it is coming. And you are going to the corresponding floor. Oh, okay. These are the shops. Okay. Grocery store, electronic shop. So he wants to go to the electronic shop. Everything by sitting in your home with your specs. Yes. Okay. It is this much cost. This is this much cost. Maybe I want it, maybe I don't want it. Okay, TV, how much? Samsung, it's an LED television, that's the cost. All right, after that, go to the next floor, go to a grocery store. Let's buy something from the grocery and look at the way that you are buying there. Okay, flour. And then some breadcrumbs, tissue, maybe water. Check out. The future of shopping. Right? And what will happen to the physical places and all those things? We don't know yet. Maybe they will become technology support centers. There are not going to be physical malls at all in the future. There might be big godowns, and you will sit in your metaverse camera, and you will go penetrate inside the shopping mall. You order all the things, delivery is at your home within an hour or so. Right? And what did you understand when you saw that metaverse? What is the crust of that metaverse application? Data. Why? When you selected the flour mill, or when you selected the breadcrumbs, or when you selected the television, how is the data shown? How the promotions can be applied? That is where our data platform also coming into picture. So data platform is going to be an ingredient or an essential fact for any metaverse applications. For example, you want to show that in Abu Dhabi there is Formula 1 going on and you want to attend that Formula 1 through metaverse. And assume that currently, unfortunately, it is raining. How will you know in the metaverse picture and in that imaging that it is raining? And that information you want to add it. You want real-time data, right? Getting that data and adding that and then showcasing it. That is where the power of Metaverse is coming in. Now getting data, right? Let us think a bit. I'm going to go to Google and I'm going to open a prompt. And the prompt I'm going to write, give me a function to get a data frame in Python. And I press enter. I have got Google search on the left hand side, and on my browser I have installed a ChatGPT plugin. And look at the different way the results are being shown. Google is giving me an explanation and thousands of links. But whereas, if you look at the right side, ChatGPT has given me the exact function that I need without writing any piece of code. So if I have a method by which I can integrate this function and call that function, which means that I can get any data that I want in my Metaverse application. So we need a system or approach by which we can get the data. Sorry, that is patented. So this particular patent, a system and method of fetching data from an external program, is a part of our solution. And this allows me to connect to anything that I want in the data field. Because now I can ask ChatGPT to generate the code. I will run it in a dynamic container, and then I will connect to that code and will get the query result. So you have IBM files, you have some Hitachi document which is lying there for last 50 years and you don't know what data it is there. You have got some printers in which you want to pull the status of the printer remotely. You have got a banking application in which you want to find out what this current customer is spending in the last 1 month. Anything. We make data democratic by this particular patent and all the other technology fixing together. And lastly, let me just show you a quick demo of how all these things are working. So I'm going to open my favorite flight server where you can see that I am running a server. Again, let me just run this particular server, right? So inside this server, I have got connections with the data. And please look at this particular tab where I am going to have some code in Jupyter which is connecting to some random places. For example, look at this code. This is connecting to Twitter. This is connecting to a particular website. This is connecting to a CSV file in my system, which is using the secret and password, everything, etc. This is code. And just now I taught you a new mechanism, because till 2 months back, my worry is, who will write this code? How many of you know how to write a complex code? Very difficult. Now I have got somebody who will write code for me. Who? ChatGPT. So, you will tell ChatGPT to write this code for you. I will take this code, run a dynamic container, and from the platform, I am going to connect it. I will show you. See, there is, okay, this is the site, right? And you can see that it is showing election results. Let me show you this website, okay, in Minnesota. So I'm going to open this tab, and I will just open this one. This is the Drake's website that I told you that artificial intelligence has duplicated Drake's song. Okay, so click enter, and this is election result in Minnesota last year. Okay, it is a Wikipedia page, and you can see while you are traversing down, you will see a table in HTML which is showing the election results. Okay, let me find out. Yeah, this is a table where the election results are there. And in Python, I have written, or in Python, it is very easy to write this particular code. So in Python, you are going to connect to this particular data by connecting to this, and then you are going to read the corresponding table in pandas. Can you query this data? Never, not possible. How can you query SQL on a code? But with the approach that I told you, that ChatGPT is generating the code and then connecting it, we can query this particular code, and that is what I'm going to show you. So if suppose you are looking at my screen where I'm running the, this is the query, okay, Control L. I am going to show catalogs. Oh, sorry, spelling. Show catalogs. What you see as arrow is the trick where we are connecting to the code. And if I am going to write show tables from arrow.default, which is the schema, look at that. API table and elections. And remember that elections is the code given by ChatGPT. And now I am going to do the magic, which no data platform in the world can do. What is that? Select star from arrow.default.elections. What you are doing? You are querying code, man. And then let us see the result. It will take a while. It is going to the website, bringing that elections data, and giving you the query. So we will overcome the snowflakes and data bricks of the world by this approach. Any data of any type, any complexity, we will be able to query, and then we will be able to combine it. And don't worry, you can join, you can do whatever you want. And if you're telling that, how many functions are there for your data platform, right? Look at this. Mathematical functions, array functions, bitwise operators, all mathematical functions, machine learning functions, geospatial functions, JSON functions, transformation, pulling the data, getting the data, aggregating the data from multiple data sources, assimilating the data, analyzing the data, machine learning from the data, deploying the data, and getting value from the data. All are possible with one single platform, which is Kubernetized, containerized, auto-scalable, sustainable, plug-in, plug-out architecture, and will save you millions. Right? Towards part of my lecture, I think I have told you whatever I wanted to. What I'm going to do now is, I want to show you a video before you are going. And that video is giving you a good message, and we can apply that message. So please watch. That is a trampoline where he is falling and getting up. What is a trampoline? The trampoline is the passion. The trampoline is the people around us. Trampoline is the vision. So whenever we fail, we will get up by that passion, by that people support, by that great human beings around us. And the passion keeps us moving. So I will leave you today's lecture with that message. Have passion in what you do and believe in Passion Bites. We will be able to give you good data solutions and data platforms. Thank you very much for listening. Please have some snacks. It will be there. Okay. Thank you. So thank you very much, team. You can log off. I think I have taken your time, which is India is 1.5 hours ahead. Vicky and team, thank you very much. Bye-bye.
Well, I just came all that way to just say these 2 words. Thank you so much for coming here. And please feel free to have some refreshments. And thank you, Ms. Ravi, for this elaboration, for an explanation, for passion by big data.
Do you have any questions, anything? Please feel free to take the mic and ask. Yeah, please. Shabir or anybody?
Shall I give you the mic?
Yeah, they are having the mic.
I understand this metaverse is going to be a thing and it's more of building the experiences and all, but I'm still confused with respect to, what is the real problem it's solving?
Getting the data from multiple data sources through simple SQL, getting that data into one place, analyzing that, then assimilating information from that, writing machine learning models into that, and deploying it. And if suppose we want to do the same kind of things in Databricks or Snowflakes of the world, first you need to know in and out of Spark. You need to know how to deploy Spark. What we have done is we have created a user interface where very easily you can do this drag and drop without knowing any complexity. That's the value add that we are giving.
That's the big data part and the machine learning part.
Correct.
But, particularly to the metaverse, which is expected to be a 13 trillion size of.
So in Metaverse, you will know that something called NFTs are available, non-fungible tokens, right? So one of the tokens, non-fungible token, will be the data platform. So whenever you are creating a Metaverse application, we will be connecting to that non-fungible token, which internally will get you the data that you need for showing it onto that Metaverse application screen. Because as you mentioned, no Metaverse scheme can be created without getting the real-time data, right, for the real-time applications. Where the data will come from? So you will have an NFT, just like your avatar. And that NFT is going to bring the data and then get the data back.
So you're saying metaverse will be more to collect the data?
Absolutely. So that is the relation. And for collecting the data, it is not very simple. Because sometimes the data may be from that website like that, what I told you. So you cannot get the data. So with that ChatGPT approach where you generate the code and then create a container out of that code, connect to that particular one and then query it and make it available on your Metaverse screen. That's what we do.
One more thing, like how would you suggest or what would you suggest to the entrepreneur or the startups to get into this field and do something, like what would be your suggestion?
There are many. Start with 3.js. Okay, there is a JavaScript library, 3.js. Please start with that. If you have any questions, connect with me.
Okay, thank you.
Yeah, thank you. Welcome. Anybody else? That's all? Anybody? No? All right, thank you.
Thank you.
Thank you very much.